What's going on, everyone? This is Kyle from Critical Synoptic Solutions to bring you a forecast discussion for today's Saturday event in Dixie Alley and parts of the Deep South. So, first, taking a look here at the SBC Outlook, we can see that there is an enhanced risk, which is a level 3 out of 5. That's going to incorporate parts of Louisiana, Arkansas, Tennessee, Mississippi, and Alabama. As we continue on looking at the tornado risk, there is even a 10% hatch risk, which means that there is a probability of 10% or greater of EF2 to EF5 tornadoes within a 25 mile of the certain point. And what's very interesting is today being the day after Valentine's Day. Maybe it's just me, but this almost looks like a heart right there, right? So is this meant to be? We'll only find out. Hopefully people stay safe. So continuing on from there, we go to the wind. And so we can see here, this is a very wind-driven event later on. That's going to be especially in parts of northern and eastern Mississippi to southwest Alabama. It's with a 45% chance of damaging winds of 50 knots or higher, which is about equivalent to, I want to say, close to 65 knots or right around that area. Now we're going to go ahead and jump to the mesoscale discussion that has been released. That's until 4 p.m. Central Standard Time by the Storm Prediction Center in Norman, Oklahoma. So if the field's plotted here, they are showing the 18Z 500 millibar height, 850 millibars, the temperature, the surface pressure, and the dew point. And it categorizes a certain area right here, that is a stationary front. So it's going to be a mix of air that is fighting between cold and warm to move that boundary, which you'll see as we continue on that boundary will go to a cold front later on. But that they believe that the corridor of intensifying thunderstorms development through 4 to 6 p.m. Central Daylight Time may initially include supercells with potential to produce tornadoes. So there's already an outlook for it and some concern. Let's go ahead and continue on from here. Now we're going to go ahead and take a look at our satellite. So we're going to look at our visible channel and then also our water vapor. So as we put this here in a loop, this will actually go. Oh, there we go. Near the end. Let's try it again. Take 2. Here we go. Okay, there we go. So you can see that there's starting to be a little bit of a clearing of the clouds. Let's just pause this later on in here. As you can see here, we put in the little area about right there, so that instability is definitely building. That's going to be right along that boundary, which they were talking about, which makes sense for why they think the intensification with the daytime heating synopsis. So continuing on from there, we're going to look at our upper level water vapor, right? Because you need as far as moisture for thunderstorms. So let's go ahead and put this into a loop, and you can see that there's a good amount of area being infected as these storms are even starting to firing, as you'll see here when I get to the next screen of our radar. But these storms are already starting to fire along that boundary, and with the lessening of clouds ahead of that boundary, that's going to increase the chance for instability. So on to the next one, we're going to go ahead and look at what the radar is looking like currently. So if we go ahead and put this into a loop, we can see that these storms are moving northeast, and they are definitely firing along that line. And with a lot of lightning right along their boundary, that is showing that there's an intensification that is currently going on. Which, if we take a look at this screen, it's got the satellite as the clouds mixed in with the radar to give us a kind of a better overlay. So we put this here into a loop. And if that will go, maybe not. All right, we'll just modify how it looks right now. So you can see that area as far as those clouds, the uncovering in that region, and then as far as have that line through here, moving off to the northeast direction. So kind of right along that, towards the Memphis area, like they were talking about, is definitely going to be a concern here coming up. So continuing on from here, we're going to go ahead and get to our models. So we're going to compare the RAP and the NAM for more of our upper air, and then we'll use the HRRR for our smaller mesoscale features. So starting off here with the RAP, we're looking at the 500 millibar chart at 21Z, which is going to be here very shortly. So if I go ahead and draw in kind of the axis of the trough, it's a little bit positively tilted right throughout this area, which if we go into more of a loop here, you can see that that is going to start to take on a little bit more of a neutral tilt once it gets into the later hours, and especially towards 06Z, which would be 12 p.m. Central Standard, Standard Time. is when more of the southeast of Mississippi into kind of Alabama threat is going to be underway, but will be for more damaging winds with a QLCS of a squall line and also embedded tornadoes. Take a look at the relative vorticity. So it's going to be as far as the amount of cyclonic spin that's going to be happening in the mid to upper levels that is going to help storm intensification. So as you can see right here, about 21Z, almost about the current time, there's a positive vorticity max that's going to be located right throughout that region. Let me circle it to just highlight more. I'm sure you can see it, but pretty much look for the colors, right? And then as we go in time, we can see that that boundary is going to start, there we go, yeah, vect more in. So when they're thinking that the real intensification is going to happen is about 0Z, which is about 5 p.m. Central Standard Time. And you can see that that's going to be a little bit right behind the boundary, right? And then as we continue on, because I even think this could be up to 06Z or 12 p.m. or even later. I really like the kind of 5 p.m. to midnight time window, personally. But yeah, there's definitely going to be, as far as a lot of vorticity, so a lot of chance for spin too. And if there's any isolated storms ahead of this line too, with supercells, would a chance of risk for tornadic development. And especially if those get merged into it, then anywhere up to that can cause an embedded circulation and a possible EF2 or greater tornado, depending on the mechanics in which that gets absorbed, known as the nudger effect. All right, so to do a little compare and contrast the 500 millibars, we're going to take a look at the NAM. So this is about 21Z. So you can see that the NAM and the RAP are pretty similar, and as far as that slightly positive tilt. If we go further along in time, let's see if they're thinking about more like kind of a neutral tilt like the RAP is thinking. Yeah, I definitely said there's a good model consensus with the way that the Rossby wave of the 500 millibar chart is going to be advecting off towards the east side. And then to compare and contrast the relative vorticity. So here we are about the time right now, 21Z, which is going to be 3 p.m. Central Standard Time. So they both have that same similar area as that vorticity maximum. And let's see as we go here in that time. Ooh, that is interesting. So the NAM's showing a little bit something the RAP's not showing right there in southeast Arkansas, which if you remember that those lines right on that boundary are definitely forming right along here. And so this is going to be ultimately moving kind of off to the east-northeast direction. So that could possibly be as far as some one of our first supercell type of developments, if that holds true. In addition, you can see with the ISO bars, you have it kind of fluctuating out to here and out to there. And that is going to be an area of divergence, which is going to increase for the chance of rising motion. So continuing on, we're going to take a look at that 300 millibar chart right now. So 21Z, about 3 p.m. Central Standard Time. So the main things we're looking for here are going to be jet streaks and also areas of divergence. So first part we can see right here, there is definitely that area of divergence, otherwise they known as the defluence of winds. So you got winds kind of going that direction, going that direction. So that area is going to create a good area of increased vertical motion. And if you remember from our satellite scan too, there's definitely a clearing of the clouds right there. So that intensity is definitely going to start to build. And then as we advance this in time on the loop, we can see that our area of divergence kind of shifts by 04Z, which is going to be 10 p.m. Central Standard Time. And that's showing as far as that area kind of there in northeast Mississippi down to our Alabama region. So that would be a good chance, depending on other metrics like instability, mixed layer K, peak layer shear, if there possibly could be some prefrontal supercells ahead of that line, depending on the intensity of the speed with which that line is moving. Now to compare and contrast, we're going to take a look at the NAM, same 300 millibars. So we're looking for those jet streaks and areas of divergence. So you can see there is a defluence of winds that are coming more from the southwesterly direction here, and down in here it's going to be more of kind of the west-southwest. So that area right in that corridor is going to increase the chance for rise in motion according to the NAM. So they both have that really similar kind of area. The NAM's a little bit more broad and the RAP's a little bit more specific, but they definitely do have a congruency with around the same region in which vertical motion is going to increase with the upper level divergence, increasing the chance for supercells. Now, continuing on, we're going to go ahead and look at our 700 millibar upper air, or technically consider the mid-level, but upper air from the surface winds. So here we are going to be looking for a couple things: short waves, which is going to increase vertical motion and uplift, and vertical velocity, which are kind of associated. But just taking a look right here, as far as about now, it's about the top of the hour, not quite. We're looking for short waves, so it's going to be, see, kind of like these little bit of some dips in those ISO bars. So there's definitely going to be an area of a shortwave there, and those are always going to be dominated by the advection, a relative vorticity, which means it will always follow the wave in which the isobars are moving. So we have one area right there, which if you remember, that line is developing right along there, so that is definitely helping the intensification, even if the cold front may be lacking a little bit behind, but we'll take a look here later on, see how that progresses looking. Then we also do see another shortwave that is kind of right there through that southeast Texas region, which is going to be moving off to the northeast. So depending on the development of this and with the advection right ahead of it, this could help with the intensification of storms going here forward and maybe the next hour. Now let's take a look of the vertical velocity of the 700 millibar chart, or pretty much of those short waves. So that area definitely lines up with the short waves with a lot of that vertical velocity happening. That is why that line of thunderstorms is already beginning to develop right along there. And we do have this an extra area that's kind of around the border of Louisiana and Arkansas, which is going to be advecting off to the northeast. So this could be a opportunity going forward, depending on the movement of this line and the speed of which it moves. So these could be prefrontal cells or supercells that before they get possibly embedded into the squall line that's developing. Now to compare and contrast, we'll look at the NAM for the 700 millibars. So once again, looking for short waves. So the NAM has a very similar location. This one's maybe a little bit progressed, just a slightly off more towards the east, but very, very subtle from the wrap. But it definitely lines up as far as that line of thunderstorms, so that they do have a good general broadening as far as that region. And they have a secondary one right before, because there could be definitely multiple short waves within here. It's not just like one short wave and then another one later on. And that's going to be advecting off towards the northeast region. So that could definitely enhance flow. And then we do see another one, which is the wrap pad as well, right through that area. So you can see here that the NAM displays one more area, but there's definitely a lot of chances for vertical motion happening. All right, so taking a look now at the vertical velocity. So it's going to be showing the vertical velocity of those short waves. We can see that they definitely match up, because if you remember, there's a short wave that was right in that area, and there's definitely a lot of vertical velocity happening. And even kind of towards the region of southeast Missouri is where you have a maximum. Depending on the feature of the low, which we'll find out here shortly when we get to more of the HRRR, it will determine on the chances as far as being maybe in that triple point and intensification, but it may be too far north too as well, depending on the instability. All right, so now looking at the vertical velocity, it's going to be looking at the uplift of those short waves. So we can see that there's definitely a lot of area as far as vertical velocity, which is happening right along that line. And there's even in that secondary area that's right along there. And with that one, if you remember that little subtle short wave that's going to be advecting off towards the north and the east. So this could definitely be increasing the chances for possible or first supercells helping in there, and maybe southeast Arkansas that may be going right ahead of that line. And then even if it gets absorbed into the line, depending on the movement of the line, that could be a chance for increased tornado genesis and possibly a strong tornado, depending on the other parameters. And so next, we're going to look at the 850 millibars, which is about a kilometer above the surface. It's going to be otherwise known as our lower level jet. So here we want levels of typically at least 30 knots or greater, but we have more than sufficient amount of that. So we can see right in that area, there is a flag and a half barb. So the flag is 50 knots and the half barb is 5. So that's a 55 knot wind. So a jet max that is happening right there. That's going to help with the lower level shear and the intensity of the squall line as it moves off to the east, since it is precursing right in that area. But even in that general broad region, we definitely have a lot of area. Like, let's go ahead and highlight this more. So yeah, as you can see, definitely nothing below 45 even. I mean, there's that one area of 44, but a lower level jet is definitely strengthening all along that area. So there's going to be an increase of the tornadic development happening depending on the amount of the daytime heating that's happening right now in that region of the clearing of the clouds, but possible tornadic intensification happening in the next couple hours. Go ahead and put this into a loop and kind of see how this is going to be developing throughout the evening. And yeah, so you can see definitely that the strengthening is going to happen, of course, during the nighttime, which is, you know, a normal occurrence, but got a jet max of 61 knots, but even a lot of that area, it's 50 knots or greater. So that is definitely going to be very significant, especially depending on the angle of the surface winds. Because if they are more of a south or southeast direction for the surface winds, otherwise known as backing, that's going to increase that lower level shear and also the tornadic development. So to compare and contrast now with the NAMI 150 millibars, so they definitely have that same area as far as that jet streak that is right along the area of southwest Arkansas and northeast Texas. But they had have a secondary 1-2 there, and that line is forming. So as that's going to be moving, that it could be possible that Tennessee's threat might be happening sooner than later, and then these areas toward the southeast might be happening later in the evening, depending on the other parameters that we can cover. All right, and then go ahead and put this into a loop. So this is every 3 hours, but as you can see, geez, yeah. I mean, the NAM's even more broad, but they're showing even a higher return as that lower level jet. So, dang, yeah, there's definitely a lot to go around and a lot of lower level jet strength, so that could be increasing the chance of tornadic development, and definitely why I see they may have put that 10% hatch risk of EF2 to EF5 tornadoes. So now we're going to take a look at the HRRR for our some more mesoscale features. First thing we're going to be looking at is a kind of like a surface analysis. So right about in the hour, they have that surface low that is right along the northwest Arkansas region. And then kind of seeing the areas between the temperature gradients, the wind shifts, also pressure tongues are kind of like similar to like the short waves. Like it's kind of the bunching of everything too, that there definitely looks to be a front, which I would say right about like throughout here. And then you would also have another one that's, I mean, this gradient kind of shows more here, and if that surface there, but this could be also too why they're thinking it's currently, because if we remember that they have, yeah, that kind of that stationary front that's going on right now. So let's go ahead and continue in time and see how these fronts on the surface low develops. So we'll go about another 3 hours to 0Z, otherwise known as 5 p.m. Central Standard Time. So this area of lower pressure that is intensifying, that's going to be more in southeast Arkansas, which you can see definitely a boundary throughout there with the wind shift and the difference in the gradient of a little bit of the temperature, and then also throughout here. So we're going to have our areas as far as possible uplift, and depending on our cape and our different other levels, such as bulk shear and theta E, we can definitely tell as far as where the storm initiation is going to be, or I should say intensification is going to be happening. Let's go and continue on from here. And then we'll just advance a couple hours from here. So let's go ahead and go to about another 3Z. So that's going to be 8 p.m. Central Standard Time. So definitely have as far as the boundary throughout here and out here. And this boundary looks like it's definitely intensifying, which definitely looks like the warm front. So I'd say 0-3Z, at least in my eyes. And this boundary in this front looks to be the most effective, but there are other metrics, right, to have that convergence of evidence. So we'll go ahead and take and see how those dew points are developing, right? So for more kind of possible stronger tornadoes and also supercell development, you want areas of 65 degrees Fahrenheit or higher typically, but at least minimum of 60. And there's definitely a lot of dew point to work with. And the direction of these winds that are coming out of the Gulf Coast means that this is over time going to be advecting even more, which is going to advect faster over this boundary, and depending on the amount of the subvection, which is probably going to raise our theta E values here, which we'll find out in a second, is going to increase the possible chance for storm intensification and tornadic development happening in maybe in the next 3 hours. So let's continue on, go to a little bit more to 3Z, to 0Z, I should say 3 hours more, right? Kind of get my words mixed up. But yeah, there's definitely as far as a lot of dew point, and we can just kind of continue on, right? I don't want to take forever for you in this video. And then as you can see during 0-6Z or about midnight, the area as far as that gradient gets a lot greater, and it looks like that nose is getting even smaller, so that they could be chances up until about midnight when things are higher chance for tornadic development. Then after that could still be damaging winds, depending on our other metrics that we can cover, but at least it's looking that way right now. So continuing on, we're going to look at our theta E values, right? So it's going to be our storm fuel, and it's also going to be an indicator as far as the instability. So there's definitely a very strong region that is happening right in more Louisiana and kind of around that area of the Ark, Mississippi, and Louisiana region. And with that boundary happening, we can definitely see it even here on with the theta E invection. They definitely have that surface low right in there, and then you have that one boundary right there. And one boundary right here. And with having this area, especially in the blues right there, as this boundary moves off to the east-northeast, that is going to increase the chance for these prefrontal cells from the squall line happening, with the higher chance of the instability and the theta E invection, which is a big crucial factor in forecasting. Let's take a look at our mixed layer cape. So this is going to be like our storm fuel. So areas you want here is at least a minimum of 1,000 joules per kilogram, but if you get 2,000 joules per kilogram or greater, that can increase the chance for supercells. So you can see right ahead of this line, it's about 1,500 joules per kilogram, so there's definitely enough sufficient energy for these to work with. And then let's go ahead and go 3 hours into the future and see how this develops. So as you can see, there's a little bit definitely more vecting and a lot happening, especially in this northwest Texas area. That's looking about pretty dang favorable coming up here in the next few hours. And then, yeah, and then right ahead of Louisiana. But as far as this, once this boundary catches up closer, I think that might be happening. But all the way in this good region here is looking very favorable coming up within the next 3 hours. And then as we put this in a loop, see how it develops throughout the night. Yeah, you can definitely see as far as a lot of that mixed layer cape that is dropping off around 03C. So that is going to be 8 p.m. Central Standard Time. And when the tornado threat might be diminishing a bit, or it could be moving more towards that area still with the mixed layer cape, to where you'd have higher chance for tornadic development in there, and then more of the damaging wind risk. That would be pretty much in those lighter areas. Since the storms in the more northern regions are getting cut off, they're going to go from outflow dominant to downflow dominant. So on the next, we're going to look at our lifted index. So minimum values we want to look for here is -4 for severe. So this is going to tell us as far as how unstable the atmosphere is. So right along that boundary, it is -5. So there's definitely enough to work with. And with the lightning happening too, it definitely shows the instability that it's going to be incurring. But there is even a bigger amount of instability that's right throughout Louisiana and also parts of Mississippi. And then I go ahead and go 3 hours into the future. So then that will be at 8 p.m. Central Standard Time. We can definitely see that there is an area that is converging. It looks like a lot of area lower level convergence. So it's going to be happening right there in more northwest Mississippi, as that unstable atmosphere is getting to levels of about -7 degrees Celsius, which is going to increase the instability. So we'll go ahead and put this onto a loop and see how it develops throughout the evening. That was way too fast of a loop. All right. So we can see as far as a lot of area that's going to be invecting into the border of Arkansas and Mississippi. And then even right here in Louisiana, which possibly with that higher vertical velocity too, that little area could definitely be increasing the chance for possible those prefrontal supercells as the squall line boundary moves off to the east and the northeast, with the chance of embedded circulations or even possibly smaller prefrontal cells happening right there in that corridor. And as that moves to the east and northeast, then the area in kind of northwest Mississippi and kind of in the smaller Tennessee border in Arkansas could definitely be under concern coming up here very shortly. Continue on throughout the evening. You can see that later on it's going to be dwindling off. That's when the area in more southeast Mississippi and southwest Alabama is going to be the highest chance for possible tornadic development all the way up until about midnight. Taking a look at the bulk share from the 0 to 6 kilometers, or it's going to be pretty much from the surface all the way up to the 500 millibars. We're looking for areas of 40 knots or greater for supercell development. So we can see that there is definitely right ahead of that boundary plenty to work with, but let's go ahead and see how this kind of develops throughout the evening. See more becomes more vected into the area, and there's definitely a good amount as far as supercells possibly happening, especially there kind of in southeast Arkansas, where that bulk shear and the mixed layer cape and the theta E convection and all those different features known as the convergence of evidence is really happening, where that area could definitely be an area for concern here at 5 p.m. coming up. I forgot to do the conversion, not 5 p.m. It would be, let's see, 6 p.m. Central Standard Time. Yeah, I'm in Mountain Standard Time. Forgot to do the conversion. And to see how this kind of develops throughout the night, yeah, we can see that there is a lot more bulk shear that is happening, and that's just going to be an indicator also, too, of that damaging wind risk happening later in the evening. Go ahead and go over to the STP, or the significant tornado parameter, and see how this threat's going to develop. So right around the boundary, we got about a 2.6, and then let's go ahead and continue on. We can see that a lot of the areas be infecting into northwest Mississippi. So we get into 01Z here in about 4 hours. So we get a 4.5 northwest Mississippi. We're going to click it for sounding. So they have a PDS tornado sounding. So let's kind of do a little breakdown on why they're believing that. So as you can see here in our mixed layer, they have a -5 value, which is going to be greater than -4. So there's our first factor. The LCL, otherwise known as the lowest condensation level, is just going to be theoretically the lowest level of the cloud base, which when it's closer to the ground is going to increase the chance for tornadic development due to the nature of the cloud being closer to the ground, so the vortex does not have to be as stretched into the vertical. And then continuing on, we have a strong 3-level cape of 129, which is going to be definitely very strong, especially anything above 100. Which we know anything from our two biggest metrics that's going to show for the biggest area of tornadic development is going to be usually 3 cape and also surface vorticity. But go ahead and continuing on from here, then we're going to see our mixed layer cape is 1268 joules per kilogram, still above that 1,000 threshold. That's looking very nice. We have a very moist layer here with a little bit of dryness right around here, but that's fine. Wouldn't be mind if there's a little bit more dryness. I could see even a vector in that area because there definitely was that shortwave right ahead, which that would make that cape even be more explosive happening throughout there. We have an effective storm relative helicity of 508 meters squared per second squared, which anything above 300 is a chance for a strong tornado. And even with our shear being 0 to 1 at 49 knots, that is really insane. Our BRN shear, which is kind of the correlation and the environment and the winds, is very strong too. So a very good chance of tornadic development with that lower level jet being 65 knots and our mid-level jet being 85 knots. And you're going to have the winds with the turning. Since you have especially those backed winds like we're talking about, right? You want it from about like the south to the southeast direction of the backed winds. And then if you remember, our lower level jet's going to be more from the southwest. And so it's going to be that 0 to 1 kilometer on why that area of 49 shear exists and why the tornado chances are going to be jumping up at 0-1Z. Until the overnight, kind of see how it progresses. You can see that area definitely gets cut off a lot more, except that area that's still prevalent in southeast Mississippi and southwest Alabama. Finally, we'll take a look at the composite reflectivity and what the simulated radar might look like, which they have it pretty accurate right now. If you remember, we have that line of storms that was definitely developing throughout there. And as you can see, they have some prefrontal cells that are definitely happening throughout Mississippi and their coordinates. Let's go ahead and see how this develops over in time. So let's go ahead and go to 0Z. And we can definitely see that, yeah, we have some prefrontal cells there in that kind of west central southwest Tennessee, and also more in northern Mississippi, which is going to be increasing the chance that those develop correctly for tornadic development, as you have that line that's going to be vected off into here. And these, depending on the movement, they're going to happen. If they're moving more northeast, they're going to get absorbed into the storm. But when they do, that's going to increase the chance for embedded supercells and also for embedded circulations or possible spin-ups. You'll look to see how this is going to develop throughout the evening. Okay, I will go a little slower than that. Which you can see, especially these areas, if there's any area of these black contour lines, it's an updraft of very strong helicity. That's going to be above 75 meters squared per second. And then going a little bit, couple more hours, we can definitely see that we have areas of strong updraft helicity, which, yeah, around that 0-1Z, right? I had that area was very favorable, right? And then let's go another hour and see a lot of that explosion happening around that line at 0-2Z. So definitely looks very favorable. And then going on into the overnight, you can see that that definitely dwindles, but that damaging wind risk along that boundary is still very a high risk chance of happening. Or I should say the best risk, not the high risk. I don't want to get parameters mixed up. But that being said, that's going to go ahead and wrap up the video. So I hope you enjoyed the content. If you did, I definitely appreciate a like and a subscribe to help increase algorithm, since there's definitely a lot of severe weather going on. A lot of people need to be on alert. Thank you for watching. We'll see you in the next video.